Find the derivative of f of x equals x times the tangent of the square root of x plus 1. So f of x here is the product of two functions, x times tangent of the square root of x plus 1. We will therefore make use of the product rule, but before we do that, let's rewrite that square root as a fractional exponent. That will be x plus 1 to the first power and second root, so 1/2 power. Our derivative overall will be a product rule of x times the tangent of x plus 1 to the 1/2. So we start with the derivative first. Derivative of the x is a 1 times the second left alone, so that'll be tangent of x plus 1 to the 1/2. Plus the first left alone times the derivative of the second. Well, the second's the tangent, and the derivative of tangent is secant squared. You leave its inside alone, but then you multiply by the derivative of the inside to complete the chain rule. Well, the inside is that x plus 1 to the 1/2, and it will follow a power rule, so we bring the 1/2 down, leave its inside alone, subtract 1 from the power, I will call that 2/2, and then we multiply by the derivative of the inside of the power. Well, the inside of the power is an x plus 1. The derivative of x plus 1 is a 1 to complete the double chain rule on the power function and the chain rule on the original trig function. In our next step, we will rewrite, we have the tangent of x plus 1 to the 1/2. We can turn that back into a square root of x plus 1 to the first power because we've taken the derivative. We only rewrote it so we can take the derivative. And then we have plus x times the secant squared of, again, an x plus 1 to the 1/2. I will rename that x plus 1 to the first power square root. And then we have this multiplying a 1/2, and we have an x plus 1 raised to the 1 minus 2, negative 1/2, and then times a 1, but anything times 1 is itself, so we don't need to write that 1 at the end there any longer. So f prime of x equals to tangent of the square root of x plus 1 plus, now the second term, what we have going on here is a negative exponent, so this I'm going to move to the denominator, which means it'll move down there with the 2 that's in the denominator. Now everything else is going to stay in the numerator, and what we have left in the numerator is that entire expression times that 1 in the numerator of that fraction. So we will have in the numerator an x secant squared of the square root of x plus 1. And in the denominator we have the 2 and the x plus 1 moved down so that it can be a positive exponent, positive 1/2. Since we have a fraction for the second term that's added to that first term, we're going to need a common denominator. So I'm going to take this first term, tangent of square root of x plus 1. I'm going to multiply it by, notice there's a 2 in the denominator of the second term, so I'm going to need a 2. But 2 times x plus 1 to the 1/2 over itself. I'll leave the second term, all of this alone, because it's already over that denominator. So that these can now be combined over that common denominator. Now the numerator of the first one will be this multiplying each other. This is not going to end up inside the tangent. The tangent will only have the square root of x plus 1 in there. That 2 times x plus 1 to the 1/2, that is outside of the tangent. So I'm going to write it first. So I will have 2 times x plus 1 to the 1/2 times the tangent of the square root of x plus 1 plus x times secant squared of the square root of x plus 1. All of it is over that common denominator now of 2 times x plus 1 to the 1/2. The only other thing we can do here is rewrite the x plus 1 to the 1/2 powers that are left over there as square root of x plus 1. So that'll include this 1 in the numerator. Let's rewrite that as square root of x plus 1. Other than that, we'll leave the numerator exactly as we see it. And then down in the denominator, we will also write that x plus 1 to the 1/2 is the square root of x plus 1. And there's our simplified version of f prime of x.